taking a look at the second part of multiplying and dividing rational expressions. So we've already found that when we're doing the non-permissible values, we know that we're looking for numbers in the denominator. If I'm looking for non-permissible values in division, then there's something else I have to account for. So for the rational expression from the first part, the non-permissible value is going to be that b can't equal 0. For the second part, it's going to be that d can't equal 0. But just like when I am dividing fractions, I'm going to multiply by the reciprocal, what's going to happen is when I rewrite this division, it's going to turn into this multiplication where I take the reciprocal of the second part, and then suddenly c is going to get added into the denominator. So now I've added the case where c can't equal 0. Which means that for the division in the type of a over b divided by c over d, we need to consider the non-permissible values at a, at c, and at d. Therefore, non-permissible values occur when a variable is present in the denominator at any time in the simplification process. So if I take a look at this, well, if I'm looking for non-permissible values in this expression, I'm looking for non-permissible values that exist in the denominator of the first part, as well as after the division sign in the denominator and in the numerator. So I can see that I'm going to have one here, one here, one here, one here, and one here. I'm going to have 5 non-permissible values in this case. When I'm dividing rational expressions, the first part is I'm going to factor, just like in all the other cases. I'm going to state all the possible non-permissible values, so remembering that if it comes after the division sign, it needs to be the non-permissibles in the denominator and the numerator, which is going to flip into the denominator. We're going to invert the divisor and then multiply straight across the top, straight across the bottom, remove common factors, and then we're going to combine everything together and see if I can reduce any further. So, taking a look at the first example. Well, here I'm going to cube out the bottom, and I'm going to say that I have 7xy squared over 8x cubed y cubed divided by, I'm going to move this negative 2y up to the top and say I have 21y to the power of 3 over 4x to the 4. I'm looking for my non-permissibles in the denominator of the first part and in the denominator and the numerator in the second part. So in this case, x cannot equal 0 and y cannot equal 0. Then I'm going to flip the divisor and multiply straight across the top and straight across the bottom. So I'm going to say this is going to be 7x y squared over 8x3 y3 multiplied by 4x to the power of 4 over 21 y to the power of 3. I can simplify that to 28 x to the 5 y to the 2 over 168 x to the 3 and y to the 6. Simplify the coefficients, and I'm just going to wind up with 1 over 6, or just a 6 in the denominator. I take away 3 x's from the top of the bottom, and I have x squared on the top, and I take away 2 y's from the top of them, I have 4 y's on the bottom, and there is my reduced expression. For example B, I'm going to match them up by pulling the negative out and putting them in the same order. And I'm going to say that this is going to be equivalent to a to the squared 3a plus b over negative 6 a minus b, and I'm going to divide that by 3a plus b squared, or 3a plus b times 3a plus b, over 2 and a to the 4 a minus b. I'm going to state my non-permissibles, which in this case are going to be a cannot equal either b, 0, or, if I look up at the top, negative b over 3. I'm going to flip the divisor and say that I have a squared and 3a plus b over negative 6a minus b. I'm going to multiply that by 2a to the 4 and a minus b over 3a plus b times 3a plus b. I can, because it's multiplication, start to cancel out. I can cancel out the 3a plus b, 3a plus b, a minus b, a minus b. This equals 2a to the 6 over negative 6 and 3a plus b. And I can simplify that to a to the 6 over negative 3 and 3a plus b. Taking a look at example 2, I'm going to start by factoring and state that this is going to be the same as x plus 11, x minus 11 over x plus y, x minus y. And I'm going to divide it by negative x minus 11 over x plus y. My non-permissible values, well, x cannot equal positive or negative y, and x also can't equal 11. I'm going to flip the divisor and I'm going to start to cancel out. So I have an x minus 11 I can take away from the top and the bottom, x plus y I can take away from the top and the bottom, and my simplified form is going to be negative x plus 11 over x minus y. For example B, I have a full fraction divided by another full fraction. So I'm just going to rewrite this in a way that makes more sense to me. I'm going to say this is going to be the same as 3xy over 9x squared minus 12x divided by 12y over 9x squared minus 16. I'm going to factor it and say that I have 3xy over 3x and 3x minus 4 divided by 12y over 3x plus 4, 3x minus 4. I can state my non-permissibles. X cannot equal 0 or positive or negative 4 over 3, and y cannot equal 0. Flip the divisor, 3xy over 3x and 3x minus 4 multiplied by 3x plus 4, 3x minus 4 over 12y. I can start to cancel out, take away an x, take away an x, take away 3, take away 3, take away 3x minus 4, take away 3x minus 4, and take away y, and take away y. And all I'm left with is 3x plus 4, all divided by 12. And there's my simplified form. For example C, same process. Step 1 is we're going to factor. So I'm going to wind up with 3 and x plus 4 over 3x plus 4 and x minus 3 divided by 12, and the 3x plus 4 can't be factored any further, and multiplied by 2 and x minus 3 over x plus 4. Now, when I'm looking for my non-permissibles, I'm looking in the denominator of the first one. I'm looking for the denominator and the numerator after the divisor, but there's nothing in the numerator. And I'm just looking for the denominator in the last one. So I'm going to state that x cannot equal either negative 4 over 3 3 or negative 4. I'm going to flip the divisor, 3x plus 4 over 3x plus 4 and x minus 3 multiplied by 3x plus 4 over 12 and multiplied by 2 and x minus 3 over x plus 4. Take away the x plus 4 from the top and the bottom, the 3x plus 4 from the top and the bottom, and the x minus 3 from the top and the bottom. And that will just leave me with 3 times 2 on the top is going to be 6 over 12, or 1 over 2. All right, for the last example, we're not going to worry about non-permissible values. We're just going to factor it down and simplify it. So on the top, I have x plus 3 can't be simplified. On the bottom, I'm going to state that it's going to be x plus 3 and x minus 5. I'm going to divide that by 2 and x minus 2 over x plus 7 and x minus 2. And I'm going to multiply that by, I'm going to divide it by negative 2, switch the places and say it's going to be x minus 5 all over 2x plus 1 and x plus 7. I'm going to flip the divisor and say that this is going to be the same as x plus 3 over x plus 3 and x minus 5 multiplied by x plus 7 and x minus 2 over 2 and x minus 2, and multiplied by negative 2 x minus 5 over 2x plus 1 and x plus 7. Cancel out x plus 3, x plus 3, the x plus 7, x plus 7, x minus 2, x minus 2, and x minus 5, x minus 5, and the 2 and the 2. Because I've canceled everything out from the top except for that negative 1, I'm just going to state that I'm going to have negative 1 on the top, and on the bottom I have 2x plus 1. And there's my final answer.